All right, now let's look at why your cup of coffee would spill over if you're driving in a car around a curve. So again, we'll draw our car. We'll say we're coming up to a curve, and we're going to be taking this, turn with some radius r while we're going at some velocity v. And then we look at our car seat, and we look at the other seat, the passenger seat, and we have our cup on it. Okay, so let's draw the forces on the cup. We know that we have gravity pushing down on it. Okay, and now the whole car, the car has a net acceleration to the left, right? In this instant, so it has a radial acceleration to the left, and so it means the seat's moving to the left with the force F. And so it's pulling, so we have a frictional force between the cup and the seat pushing the cup to the left. So ideally you would think, okay, well, this means the cup should move to the left, so it shouldn't fall over because we have this force. But remember now, in this inertial frame, we also have what appears to be a frame correcting force, right? This is going to be acting on the center of mass of the object. So we have a frictional force here on the bottom, but we have this frame correcting force. So these aren't being applied to the same place, right? We know that if we had something, if we had like something here for the cup to lean up against, then when we take the curve, it's no problem. Like, for example, if that was our hand, or if we prop something up there that was sufficient, then it wouldn't knock over. But in the absence of anything being there, what we have is we actually have a torque about this point here. So that as we continue to take the curve, this frame correcting force is applying a torque to the cup, which is this distance r cross f. And so it's this cross product of these two that gives us a torque, and that's why the cup tips over. It doesn't just slide, right? It actually tips over, and then your water or coffee or whatever ends up spilling out. And that's why that happens is, if you look in the inertial frame of the car, it's because there's a torque being applied to it. Of course, again, as we mentioned before, what's really happening is the cup's wanting to move straight. Because it's in the car, it's wanting to move straight. You're accelerating this way. So again, you still have, a frictional force that's trying to pull against it, but you have the cup's inertia, its momentum trying to pull it forward. And so it's the fact that you're then you can look at it as it's your friction about the center of mass of the cup, and that's actually what's tipping you over. So it's two different ways to look at the same problem. And so now we've pretty much touched on all the topics that are going to be on this unit exam. So you're going to have one problem that's just going to be a circular motion problem, where you have to do something with orbits or cars going around a turn or something like that. And then you're going to have one that's going to have to do with these inertial reference frames, either inertial or non-inertial. And so it's going to be asking you some kind of conceptual question with maybe some small calculation in most cases, for you to figure out what's happening in a given situation, while you're in this inertial or non-inertial reference frame.